Yeah, we are live. We are live. It is 7. Oh, it's before 7 o'clock, 6:58. Hope you guys are all having a good weekend. We are here. We have, I was actually just out baking. You know what? I'm never going to go back now. Angel food cake in cupcake pans with none of the cupcake wrapping stuff. You get the whole muffin top and all the angel food cakey goodness, because anybody knows anything about angel food cakes knows that the top part's just a little bit done. That's the good part. And then you mix that with raspberry lemon drops. Uh, Excellent stuff. But tonight we're not talking about baking, because that's not what we do here. We're talking about Boost, and Boost for everything. I'm sure you guys know, everyone, I'm sure everyone here and myself included, big fans of Boost. And the most recent video that I put up today was all about that, about why everybody should be, adjust this just a little bit, why everybody should be adding Boost to everything that they have. And if you take a look at the thumbnail for this video, you'll see that back in the day, and this was that was not terribly long ago. I mean, it was probably been a couple of decades, but and I, I was like a lot of other people, is that everybody thought that, you're sitting at home thinking, okay, I have a motor that has a cat back on it, or maybe a tune, or if it's an old carbureted motor, you have a 4-barrel on it, a 3/4 race cam, or 7/8, or whatever the number is. But you have some kind of combination. It's fairly mild. You're thinking, you read about all of the stuff. If you've read any of Gail Banks' stuff, like from back in the day, like I did, or you've seen the stuff that Matt's doing over at Sloppy, or anybody else, you're like, man, I would really love to turbo on my motor. I just wish I could. Well, here's the good news. You actually can. Because if you look back at the motor, the thumbnail that I put up, we basically threw everything at it. Okay, it's going to run Boost, so we have to have copper head gaskets and head studs, and I think we were thinking about O-ringing the block, and we had really good heads on it. I think we had Airflow Research heads on it. We had a turbo on it that was about 9 times as big as we needed. It was a big T6. It was an 88 or a 91 millimeter T6 deal from Turbonetics. We had a 3-inch Y pipe on it. We had dedicated tubular headers on it. It had a big cam in it. It might have even been 400 inches. And, it's just all silly for the kind, we're trying to get into that 4-digit power level. Well, we know that none of that stuff is necessary. In fact, we can go 1.5 times that for about 1/10 of the price that it would cost to duplicate that kind of motor. And it's just not necessary. And it's not even about that really so much as the video on Boost really is just more to show you what the possibility is and how easy it is to do it, and to not just put Boost on it and go, okay, I'm going to go from 300 to 400 horsepower. That's very easy, but it's easy to go from some number, 500 or 600, to 700 or 800, 900 or 1,000, or whatever the number is. It's pretty easy to get major percentage gains, even 100% with Boost. And all you have to do is make sure some of the things are right. You can put the wrong turbo in it. You can put the wrong size wastegate on it. You can put the wrong size Y pipe on it and the wrong size intercooler and stuff on it. If the tune is there, which is a critical thing. And one of the big problems is, and I'm going to do a video on like the top 10 problems people have with turbos, with trying to turbocharge anything, because they're all the same. It's all too small of an injector, too small of a pump, not something as simple as, which they go through all the time on the chassis dyno side, is not checking your fuel filter. You have no idea how many times people come in with clogged fuel filters and not enough fuel system to do what they need to do. All of the rest of the stuff is there, and they have enough turbo, they have enough motor, they have enough sealing, they have a good enough tune. All of that stuff is working, but they don't have enough fuel flow. Even if they have enough injector, they don't have enough pump, and they might not have enough of one or the other, because you can kind of balance that out. So I want to go into all that and tell people some of the common problems that are associated with that, and that will be a lot of fun. But like I said, we did everything on the motor, and none of that was necessary. I mean, if I look back now and think, I could have just gone over and got a 5.3 from the wrecking yard and put, ring gap in it and head studs. And really, for 1,000 horsepower, we could have done it without head studs. But head studs and new gaskets. A lot of times Matt over at Sloppy reuses that stuff. I haven't reused the gaskets that we take off from the wrecking yard very often, or ever at all, if I remember right. only because they tend to get damaged when you peel them apart. So I would not be as worried about the sealing in the compression, but the water and all of that stuff. So I've not done that. We've reused head gaskets a lot when we put new head gaskets on, and then we swap heads or something like that. We just keep using them because you haven't damaged them, and they haven't like over 10 or 20 or whatever years, and I don't know how many heat cycles and stuff, they've become one with the cylinder head. At least all of the sealing stuff for the water, and it just gets problematic. So I don't do that. I put head gaskets on it. If you put you could put a cam and springs in it, and then bigger injectors, and like I said, a pump, and add boost, and then away you go. And like with a 5.3 or a 4.8, or if we could find a 6.0, that would also be nice, or anything. And we always talk about, when we're talking about boost, we normally bring up LS stuff. But the reality is, and that's probably one of the things I wanted to talk about with the video that I did, is that you can apply that to anything. If you go get an L31, or you go get a 2J, or you're not going to find a rotary or anything. At least I've never seen one in the wrecking yard, but you might be able to find that. But a slant 6 or a 292 or an Atlas or whatever it is, all of those things you can add boost to. Now, not all of them you're going to be able to make 1,500 horsepower, but that's usually not what people want. Like when I was first doing this stuff, when I had my Camaro, I wish I would have put it in my 260Z. I definitely wish I would have had boost back in the day. I put side draft Webers on it, which was really, really cool looking, but it adds nowhere near the power that like 7 or 8 pounds boost would have been. I remember racing a guy that had a turbo in town, and he had a turbo on his Z, and his was a lot faster than mine. It just wasn't even close. So any kind of boost makes a big difference. So adding like 50% of power, which is a huge jump. I mean, it takes a lot of NA modifications for you to get that kind of gain. And more likely than not, you're not going to get a 50% increase in torque, which you do get with boost. So even if you put it on a stock 5-liter Mustang engine and you increase torque by 50%, it takes a lot to do that with heads, cam, and intake. Usually you have to do it with displacement and compression, things like that really make a difference in torque. But a 50% increase in torque is a lot. And with boost, you can do that. And that's really what feels good in accelerating the car. And the guy in the little Z that I was talking about, because he now had torque, which we didn't have, being a 6-cylinder, being a mine was a 2.6 liter 6-cylinder. He had V8 kind of torque. And so he would stomp on a lot of people with that car. And it was super cool. But that's the great thing about boost. And a lot of people think, and I was one of them back then, I wouldn't have dabbled with that because I didn't know anything about it. It was all magic. I had read all of the books and stuff from Gale and Hugh and all these guys and Corky, and this was even before Corky, but I wanted to, I couldn't do it as much, even if I wanted to. I didn't think that it was possible. I thought that I had to build like a real dedicated motor, and I had to know a great deal about this. And you don't. What you have to know with the turbo is you have to get the exhaust to the turbo and make sure it's all sealed. And then you have to get the boost, and then you have to control the boost, and then you have to tune the boost. And that's really it. So you can put that on a just completely stock motor. And if you got a 50% increase in power, that would really be noticeable. And it's a nice thing for a lot of applications that don't have like a lot of aftermarket support. So if you're trying to do something like an international harvester motor or whatever, guys have mentioned those. Let's say there's not 15 intake manifolds available for. Let's say that there are no aftermarket cylinder heads for them, kind of like we're looking at with a 3800. Even if somebody there are applications also that people don't make cams for, that you have to have a reground stock cam, or you'd have to do your own like billet kind of cam. So for applications like that, boost makes a lot of sense. And it's the nice thing about it is the boost doesn't care what kind of motor you have. The turbo doesn't care that they don't make intake manifolds or cylinder heads or camshafts for your particular application. Excuse me. It's like, hey, I'm boost. I'm here to party. Let's go. Let's make this happen. It doesn't matter that the whole industry doesn't love your application. I do, because I'm boost and I came here to play. So that's the great thing about it. And like I said, having, and particularly with a turbo, to some extent with the blowers and stuff, because I ran around with a blower on my 5-liter Mustang for a really long time. And the car, especially back in the day, was fairly fast, but not like it is with a turbo, because a turbo has, you know, like we've talked about this before, the centrifugal has a rising curve. So if I have 8 pounds at the top, the turbo has 8 pounds here and here. And so all that stuff in the middle, that's like torque and acceleration. So it makes a big difference. And it demonstrated in the video 3 different applications where it was very easy to make. In this case, I just selected a number. We picked 900 horsepower because I had a whole bunch of them that would fit into that, and actually limited the number that I put in the video because it would just keep going on and on and on. Hey, here's another one that made 900. Here's another one. Here's another one. There's lots of them. And the interesting thing is that you can see that it takes different amounts of boost depending on, and you guys should all know, depending on the starting point of the NA motor, because it takes less boost on a 400 horsepower motor to get to 900 than it does on a 200 or a 300. And it takes less on a 500 than it does on a 400. So the more powerful your NA motor is, the easier it is to get to any power level. In this case, it was a little over there. They all exceeded 900. And we did it with a 4.6 liter 4-valve modular Ford motor that was originally an 03 Cobra motor. So it was a perfect one. It was designed for boost. We ended up putting cams in that and then ran twin turbos on it, and it worked very well, because that's what boost does. If you have it right, it will work very well. And then we also did it with an LS, which again is a natural kind of thing. And I didn't even choose the Big Bang motor, which we could have done. You know, we did lots and lots of power with that stuff. But we picked a single turbo. I think it was a single. Was it a single Summit or yeah, it was a Summit, I think, that we ran on that, and it made, you know, the Summit was capable of going more than that. I think we made 915 or 920 or something like that. And it could probably go to 1,000 because it was an S475, but it was a T6 S475 with a 1.32 AR on the hot side. And so it was big enough that we didn't have to worry about hot side exhaust flow. We could max out the compressor side of that with that 5.3. The thing I wish we would have done on one of these combinations, or 2 of these combinations, I ran a manual wastegate controller, not the electronic TC1. I think on the big block we ran the TC1, and that worked out well. Except with the TC1 on the big block, I wish that we wouldn't have run that. I wish that we would have run it. Well, I wish that we would have run it, but I wish we would have run it with an RPM reference, so we could have had lower boost down low. Because you see that thing made almost the same torque as it did horsepower, which is good for the average guy wanting to drive around and have lots and lots of torque and spin the tires and go fast and all that. But for eventually we wanted to do the Big Bang with that motor. So we don't want that much torque. We wanted to make a lot less torque than it makes horsepower. So what I wanted is that thing to make power at a higher engine speed and then not make nearly that much torque. So what we need from the electronic controller with an RPM reference is that we need the boost to increase with RPM. And I think we have that now. I think Eric has hooked that up at West Tech. I haven't tried it yet, but it's definitely something that we want to do. And that can come in handy for a lot of applications where you don't want to have because usually, like with all the Big Bang stuff, when we do break something, it's almost always a rod. And we usually do that because of cylinder pressure loads. It's usually a torque application. So if we can limit that, we can get to a big power number, which everybody on the internet wants to see. And so we can get to a really big peak power number and do it safely. And we know that the torque kills these things because when I did the first one, we did the first 4.8 for hot rod way back in 2010. We ran, I don't know, 70 or 80 runs with that thing, and it just kept going and going and going. And you know, we were making mistakes and doing dumb things, but it kept being alive and being happy. And then we thought, well, you know what we should do is, I wonder if we're getting contamination in the room. We weren't at that power level. It wasn't an issue, especially running gas. We were running race gas in it. When you run methanol on some of those things, you need to start to worry about that. That's why you want to have the exhaust be all the way back in the back and aimed up at the exhaust fan. But that wasn't an issue, but we wanted to try loading the motor at a higher engine speed so that the run would be shorter. That's a big mistake, because the 4.8 liter with a stock bottom end, Gen 3 bottom end, no less, will take lots and lots of runs if you loaded it like 450 or 500 foot-pounds of torque and then release it. And then because we had 2 turbos that were oversized for that particular motor, we had a fairly good sized camshaft in it. So it just came up on the cam and came up on the boost. It didn't do that till later. So it would make run after run like that, but it won't do it, you know, an 800 or 900 foot-pound stationary load as we load into it and then release it. And that's actually what ended up breaking it, is not because what we were doing for the Big Bang, trying to go for a big number. It was that we shortened the load and did a really high torque number stationary load on it. It's just like, nah, we don't like that. And you know, after 70 or 80 poles that are 4-digit power level poles, you know, maybe we're starting to weaken things. You know, there's no way to know. And again, we know nothing about the motor before I got it from the wrecking yard, other than it was a wrecking yard motor. It had a big stain in one of the walls. We ran it anyway. I mean, we just put ring gap in it, and we surfaced the deck of the head. I think the head was already done, because I think that was a ported 706 head from TEA back in that one. And then we surfaced the block also, just so that I could make sure that we got sealing. I didn't want sealing to be the limiting factor on what kind of power it would eventually produce. Honestly, back then when we first did that, I had no idea it was going to go to like 1200 horsepower. Nobody did. I mean, everyone thought that was just that was a lie when we first did it. But like I said, we made lots and lots of runs that were over 1,000 horsepower. And and now subsequently we've seen that lots and lots of people have done that and done way more than that. And there's certainly a lot of potential there. But turbos for everything. So if you have something, if you have a Buick, if you have an Atlas, if you have a Cleveland, I remember seeing back in the day, guys would bring these Clevelands out in the Panteras out to the Silver State race. And we used to call it the Pantera Graveyard, because it seemed like everybody that brought out a Pantera, which I love, especially like the GTS or the GT5 versions with the flares and the wings and stuff all over them, so they look a little Lamborghini Countach-esque. They were awesome looking, and the engine compartments are like detailed, and some of them had twin turbo deals and, you know, all kinds of cool Clevelands and stuff in them. And then invariably they'd all break. Most of them would overheat. They had cooling problems. But it seemed like on a few races, things was just littered with Panteras. So they didn't have a really good reliability record, unfortunately. But I really like the cars. But if you have a Cleveland, you know, you certainly can turbocharge that. Any 351 Windsor, and I want to redo the Big Bang Windsor deal with a turbo on it, because I think we didn't give that one a fair shake. The big block I'm definitely going to do. But anything that's a nice thing. You go find anything there, a little Mazda engine, you know, a Duratec engine, whatever it is, even if somebody doesn't cater to it, the turbo does, because, you know, boost is good on everything. So let's see what you guys are doing on a Saturday night and find out if you guys have watched the video. And if you guys have any questions, let me know. And time to hit it up. Let's see what we got going on here. Mr. Virus, I get 30 miles per gallon on my Caravan highway. I just make sure it never goes over 1.8 thousand. So 1,800 RPM if you're cruising RPM. That must be a pretty slow speed then. The balance weights on the Gen 3 and Gen 4 stuff are definitely different. Have you explained a cheap carb for a turbo? I don't know of one. I've never redone one, converted one to make it work as a blow through. We've only ever used the CSU one. I think we've also used the quick fuel stuff, but I've never done a do-it-yourself kind of thing. And I don't know of any low buck ones. JPL, I am boxing the intercooler up this weekend. It'll be out the beginning of the week. Thank you very much. Any downside to running twin turbos off a single exhaust? I don't know why you would. I remember Pantera with a 1968 large Journal 327 Chevy. The fastest Pantera that was out there was, God, I'm trying to remember the guy's name. He had a big block in his, and his was really fast. I've never run a turbo on a flathead, but the Flatfire engine, which is now Speed Demon, they used to have a flathead in there with a Vortec on it. So Admiral, you started watching the video and then came this way. Well, good. You got to be here for the live feed. That one will wait. JPL, what do you think a good set of heads is worth on a supercharged 3800? Well, hopefully in the next week or two, I will be able to let you know how much it's worth. I think what we'll see, and what we almost always see on any application, is if we have two-cylinder heads and one flows quite a bit better, which I think we're going to see. I don't know. I'm thinking a fully ported set of heads is going to be 30 or 40 CFM better than the stock head. If we have that head and it flows that much more, if we have enough motor to take advantage of what the ported head has to offer, we're going to get greater gains. If you take that ported head and put it on a stock motor, you may get very little with a stock cam and a stock boost level and all that. The other thing is, I suspect that you would get less of a power gain on a supercharged motor than you would on the NA motor. I'm going to test it both ways, so we're going to find out. I don't know if the boost makes up for some of the additional airflow, at least on the intake side. But it's an interesting question, and it'll be definitely worth a test. I'm dreaming of built T56s and exploding 10 bolts. LSA motor besides LS9 cam. Any other recommendations for something that idles standard? There are a few other small blower cams that are out there that make a big difference. The other thing I was thinking about is I think you should think about not having a blower cam in that. The LSA cam and the LS9 cam are both pretty soft down low. The LSA not as much as the LS9. The LSA makes a lot less power than the LS9 does at the top. But you can choose an aftermarket cam. If you take a look at some of the videos I have up on comparisons with the LS9 and other aftermarket cams, you can have an aftermarket camshaft that makes as much power as the LS9 does at the top, but makes a lot more down low. And it actually has less. It certainly is going to probably have a lot less exhaust duration than the LS9 cam does, and a lot tighter LSA. And it'll make a lot more of the middle part, and it definitely will work with a blower. I have run a single exhaust to twin turbos. We did that. I did that with Tom on the Volkswagen that we tried to do, because we had to run in a class that required a turbo. Well, our motor already had a turbo because it was a turbo Volkswagen engine. And so we had to add a second one. And so we ran an exhaust from the head that I don't like that merges all the exhausts together. And we ran a single exhaust out of that. And I think that was 3 inches, which we shouldn't have done. It should have been smaller than that. And then we did a Y. Tom did a really nice job on this exhaust, by the way. We did a Y into 2 small turbos and then blew those into the I laugh because there's a good story about that. And then blew that into the intercooler and stuff. My GTO at 2000 RPM, 70 miles an hour. Yeah, that's pretty normal for the GM stuff. Scott, how about twins for a ZZ454 streetcar? Yeah, that would work good. I've run a couple of 454 crate motors from GM with boost. I don't think I've done turbos on them, but I know I've run Pro chargers on them, and that works good. You don't have to do twins. You can do a single, but whatever fits in there. And if you like the look of twins, because it definitely is symmetrical. Have you done a really high competition turbo LS? No, I don't do that stuff. I stay away from that. There are guys that specialize in that make really high horsepower stuff. Most of the people that watch my stuff and the people that I'm interested in talking to is not that. In fact, I have this discussion with the guys from every supercharger manufacturer and every turbocharger manufacturer all the time. And they're like, yeah, we need a turbo that's capable of supporting 3,000 horsepower. I'm like, yeah, for the 5 or 6 people that would actually buy that. And half of those guys are going to want it for free because they're running in a, they're running on Street Outlaws, or they're doing no prep stuff and they're getting a lot of exposure and they're going to want the thing for free. You don't want that because you're not going to sell very many of those. And it's the same thing with these really high horsepower competition engines. That's a very, very tiny, limited market. And I'd rather cater to the people that go to the wrecking yard like I do and do that kind of stuff. AMSOIL gave me 3 miles per gallon on the highway. That's not what did it. Oil won't do that. What would you say could use a 143-pound injector? Boosted is fine. I run 1500s in a lot of the stuff that I do. It's fine. It works fine. My turbo 6-liter didn't blow up. Well, that's that's a good statement. When's the next Westech collaboration? That was hilarious. Which Route 66? Which one are you talking about? Dave, that's a really good question, and it's a difficult answer. How do you know which part of the turbo cold side or the hot side is maxed out? You can get a fairly good idea if you have compressor maps on them, actual compressor maps, and then you know what the airflow through the motor is. Like if you have a mass air meter or an air hat on the engine dyno, we could plot where we are on the compressor map, and so we'd know at least on the cold side where we are. We get a fairly good idea about what's happening on the hot side based on the back pressure. So if we start seeing really high back pressures, we start getting, and we would also start looking at the power level too to figure that out. And then you could make changes to either one of those to figure out if it is the hot side or the cold side. Talk spool time versus crossover. I think you affect crossover spool time a lot less with a crossover size than people really think. I think you're looking in the wrong area first. I think that's secondary or tertiary for where I would look for spool time. You need to look at the power output of the motor, especially the low speed torque, versus the turbo sizing. That's the big thing. All the other things are little things, and including the spool time. I think if you went from a 2 to a 2.5 to a 3-inch Y pipe, I'd be surprised if you changed spool time very much. Oh, so Admiral, you're getting a loan for the nitrous? Nice. Hoon Squad TV, so I'll be okay with 650 rear wheel horsepower and Gen 3 5.3. You're saying the rods will be fine. Like I said, I've run hundreds of runs on Gen 3 motors with way over 1,000 horsepower. Like the Gen 3 6-liter made 1482. And it had lots of 4-digit power runs on it. So yeah, you would be fine as long as your other things are fine. As long as you have ring gap, as long as the tune's right, the temperature's right, all of that, then yeah, you can get away with it just fine. And for 600 wheel horsepower, you could run a long time with that. Single turbo sizing for a stock displacement street strip LS3. Travis, you got to tell me if you're going to come here and hang out, man. You got to tell me what the power output is. How much power do you want to make? And that's going to determine what turbo we tell you to get. If you want 700 horsepower, GT45. If you want 1,000 horsepower, S475, VS Racing 7875 on an LS3, I wouldn't be opposed because that's a really good motor and it makes good torque. I wouldn't be opposed to going to an S480. Tim, I'm sure, is going to chime in with some sort of whole set HX50 or something. Springer 406 small block, 12-1. Solid roller, looking for 550 to 600 horsepower. That should be fairly simple. You don't even need to have that much compression for that. Brodix or AFR heads, both of those heads will easily do that. They'll support that power level without any problem. Both of those guys sell heads that flow over 300 CFM for a small block Chevy. So you just need a good enough camshaft in it. Something that would be a 264, 268 kind of thing would probably do that. Admiral, pretty sure on just about everything out there, pistons are going to be the failure point. Not on the LS stuff. The LS stuff seems to be rods. What about using hydrogen peroxide? I think that they tried that back when they were doing the test. Hydrogen peroxide is one of the many things that they tried when they were doing the stuff for World War II, because they tried pure oxygen. They tried a lot of different things, and I don't think it had the gains. And I thought it was like volatile or corrosive. Pros and cons of a draw through versus a blow through. Not very many people do draw through turbo stuff. Almost everybody does a blow through. The one big problem is that you're going to limit power output on a draw through, because on a draw through, the sizing of whatever you have in front of the turbo or blower, whether that's a throttle body or carburetor or whatever it is, has to be a lot bigger because it flows a lot more under boost. So if you have for instance, if you have I don't know, let's say a 80 millimeter throttle body. Well, you can make 1,500 horsepower with an 80 millimeter throttle body if you're blowing through it. If you're drawing through it, you're not going to get there. Thanks for the information, Richard. I have watched your videos. Most crane cams you've used have low 112 to 114 LSA or so numbers, so they won't idle rough and won't people know, and you don't want people to know you have an aftermarket cam. The LSA is one of the things that dictates idle quality. But if you have a 264, 278 cam and it has a 114, it's not going to idle that great. What do you think about a 5.3 with a 241 cam and an LS6 intake from a GTO? Wiener bacon. If you take a look at the video that I have up where I tested all of the factory camshafts, you can see what that LS 240. I'm hoping that a 241 cam you're talking about is that the head designation? If it's any kind of factory cam, I tested all the factory cams, and so you can see exactly what that combination is going to do. So I'm not sure what the 241 designation is. Are turbo guys running a PCV system? I don't like them. I vent them to atmosphere when I run them. Brian, you have an 89 Corvette tune port, so it's an L98. You're replacing the gaskets on the intake, I'm assuming. Is there any benefit to port work? Not on the port matching the intake is going to be worth very little with a stock cam and everything else being stock. Fully divided twin scroll turbo setup worth it? If it depends. It only works if you need the thing to be a lot more responsive for a particular reason. So are you trying to do it because it's generically better than not having it? Or are you trying to do it because I have a really big turbo on a small motor and I'm having trouble spooling it, and I don't want to have a 6,000 RPM stall converter, and I want to get this thing to launch, then you have to start looking at stuff like that. When we put turbos on these engines, on the engine dyno, I don't even look to see if they have a divided housing, and none of the Y pipes or anything I do are fully divided. Okay, JPL, thanks for the heads up. I will go ahead and clean the rails inside and out. I don't know why you'd want to polish them. That's not necessary for what I'm doing. We don't care what it looks like. Performance engines, power potential with twin 57mm turbos on a V6 Chevy. So it's a 3-liter and it makes 375 horsepower. And the twin 57s will probably, if they're good twin 57s, will support over 1,000 horsepower. Hey, what are you doing there? My backdrop is trying to drop back. 68 C10 with an LD28 diesel. The head will flow 330 total CFM. I don't know, Speed Racer. I don't know about. I don't do a lot of diesel works. I mean, the only diesel stuff I've done is I had a Dodge Cummins turbo diesel. But the head flow means nothing compared to what the turbo flow is. That's irrelevant. I mean, you having the head flow can improve the power. What you would be interested in is total flow of the NA motor versus the flow potential of the turbo. If the NA motor flows 650 CFM already, then having a turbo on there that only flows 650 CFM is not going to be worth very much. It's going to be worth some down low, but not where you have maximum airflow. Burning tire. I didn't see. Scrolling back a little, but I didn't see what you're talking about. The high compression. How much nitrous can a stock bottom end LT1 engine handle? Are we talking about the 1970, the 96, or the 2015, 2020, or whatever LT1? Which one are you talking about? Tucker, that's very cool. You're at the wrecking yard today picking 862 heads. You should just grab the whole motor. It's cheap, right? Thinking of a turbo 6-liter LS as a carb fine or fuel injection. Either one of those work. I like the fuel injected manifolds typically better, only because the runner lengths are all even usually on them. And there's a lot of different ones to choose from. Lots of guys do blow through carbureted deals. They typically do a single plane intake. The only thing I don't like about a single plane intake is it has 4 long and 4 short runners. They're optimized for power production in different RPM ranges. They throw the air fuel curve during the RPM run all over the board. It takes a lot of tuning to make them right. So I like, all the long runner stuff, like the fast on that motor works really, really well. So Tucker is saying that E85 went up a lot more than 91. I haven't done a price comparison. Maybe I should stop talking about how great it is. I should start telling people how terrible it is and that nobody should buy it, and then maybe the price will come down. Tom, I did not find a Trail 90 yet. I would like to, though. I bet the MBE game change. Every time somebody says this is a game changer, it reminds me of the guy Todd from Gold Rush used to say that every freaking episode. Oh, this is a game changer. What size turbo would you recommend for a ZZ454, Scott? Again, S480 for a 454 making 1,000 horsepower. You can go down from there if you want to make less than that. Steve Morris videos, easy 500 horsepower with 70 millimeter cores. What is 500 horsepower? 500 horsepower like an NA big block? That doesn't seem like it's very much. Danimal, did those early 80s Pontiac 4.9 liter turbo engines run the turbo off the passenger side exhaust bank only? No, they actually used both. But Saab did that on their asymmetrical V6 turbo. Oh, Route 66, the blue jug. Yeah, that was fun. Google and S480 fits on everything. Low C, how about a 2012 Chevy Impala LFX V6? I haven't ever run one of those. I'd never even looked for one. Brian, 1937 Hudson. Yes. Is it a Hudson Hornet? Can I add turbo to the stocks? 40,000 mile, 212 6-cylinder splasher engine. Original horsepower was 106. Yes, you can add turbo to anything. I don't know how you're going to do the oiling for the turbo though. Maybe you have to get one of those turbos that doesn't have oiling for it, or maybe just a centrifugal blower or something. That one of the self-contained ones. Duke's Mopar Garage. How much boost do you think a stock internal can take on the 5.9 Magnum? I don't know. I don't have any experience with boosting a Magnum yet. Do you think the S475 more or less than the S7875 for a 6-liter? Or looking for which pools quicker? I think most guys determine which one of those they want based on price more than anything. I'd have to look and see on spool rate. Most people on the S475 get a T6 version because it's a lot less expensive. Most guys don't go for the T4 version. And on a 7875, a Gen 1 or a Gen 2, that's going to be a T4. And so the T4 is probably going to spool quicker than the T6 does. Spencer, I don't know what an S256 turbo is. And you have a 440-inch 340 Mopar block motor? So you have a motor that's 100 cubic inches bigger, but you're not trying to make big power out of it? The guys that are saying that a 7875 will spool quicker than the S475, I don't agree with that. I have T4s on both of them. But the thing is, you have to look and see if you have, what do you have? Do you have the same AR on both of them? Do you have the same wheel size? There's an awful lot going on there. But the T4 is definitely going to should spool quicker than the T6 S475. Can you do a small block Ford dyno out of the box Victor Jr. heads, which I don't have, versus AFR heads, which I don't have, and AFR has a bunch of different sets, so I don't know which one you're talking about. I have Victor Jr.'s. I want to see what I'm missing out on. Unless you have the rest of the combination where you have maxed out those Victor Jr. heads, and then because the AFR heads are a better head, they make more power. Did I test Victor Jr. heads in my big head test? I can't remember. I've run those heads before, and I don't remember them being spectacular. An airflow research head is definitely going to be better. But the thing is, it's not that's not the question. We already know the answer to that. So if you have a Victor Jr. head versus a 185 or a 205 head, the airflow research heads definitely can make more power. The question is your combination needing whatever extra the airflow research has to offer? If you have a 302 with a E cam in it and you have Victor Jr.'s on it, you're going to get nothing from the airflow research head because you don't have enough motor to use what it has available. So it's going to depend on a lot on your combination. Admiral, if you're running two-stage injection on a 3,000 horsepower V8, what size would you use? I'm going to pass on that. Watched the Engine Masters piston flip video yesterday. Freiberger did a great job on that. I thought his whiteboard chat, and there's a backstory behind that, which is really, really funny. But Freiberger was very, very impressive on what he learned, all the information that he sought out to try to figure out, so he would know, so he could explain this and understand it and get to the bottom of what happened and why we think happened and why what didn't happen. So he talked to a lot of different people to get information on that. I was really impressed with the level of technology that went into that. It's way more than was out there beforehand. Richard, I'm building a 5.3 liter LS forge rod and piston, 243 head. Do you think a 625 lift, 232, 238, 112 will be big for a daily driver turbo? I don't, Michael, if you're building a 5.3 and it's a daily driver and it's a turbo, I would go down about 20 degrees of duration in that camshaft. You don't need that camshaft. At least 10. You don't need anywhere near that much camshaft to make power for a daily driver, or even for not a daily driver. If you have 1,000 horsepower turbo on it and you have that cam like I have, that 219, 225 cam that I had, you can do 1,000 horsepower with that, and it will idle better and it will respond better and it will do everything better than that bigger cam will do. Randall, you experimented on a big block, twin turbo, spools one up and then turns on the second. So it's like a sequential deal then? You also have a problem with that routing the cold side of that as well, because you have to have the single turbo that's blowing into presumably an intercooler not backfeed the other turbo. So it's a lot of valves and stuff going on there. Jaw dropping is an 800 horsepower turbo, capable turbo, total horsepower or 800 horsepower on top of the NA output. It's total. If you have a 400 horsepower motor and you add an 800 horsepower turbo to it, it's 800 horsepower. Tim is saying that the exhaust housings are probably big. That's a 440-inch motor that he was talking about, Tim. I think he probably will be okay. Casey, a lot of VW guys do draw through. That's true. They do that. But also the one of the benefits there, well, they would get that either way. They're not limited in power output on a draw through VW motor. So if you have a, I don't know, 1.5 to 2.5 liter VW engine that's making 200 horsepower NA or less, which is, it's more than likely going to be less, and you're making 300 or 400 horsepower, let's say, on a turbo application, and so you have a 650 or 750 carburetor feeding the turbo, all of that is sized so all of that works out. If you're trying to do it and scale that up and you're trying to do it with a 1,000, 1,500, 2,000 horsepower motor, all of a sudden, what size single carburetor do you use on a 2,000 horsepower motor? You don't. You use multiple carburetors on that and a big tunnel ram and all that. So that's where it gets to be a problem. On a low horsepower deal, it's not a problem. I've never tested a 3.6 liter LFX engine on anything. I don't ever remember even seeing one. Mr. Virus, Chevy did have 18-degree heads. They still do. I don't know if Chevy has them, but somebody still makes a. I know Brodex makes an aluminum head for the V6, but it's not the Vortec head. And I thought that they had an altered valve angle head too. I'm trying to put an M90 on my V6. You just need to have the right adapter placed. Bradley, just send me an email and I can tell you about the. You can't pick it up locally. It has to be shipped. So you just have to send me an email and let me know if you want it. Tim, what did the HP Performance Twin 57s make on the 4.6 liter? We made almost 1,000. I think 996 or something like that. I don't know if they were turned all the way up or not. Oh, I guess I was pretty far behind on my questions here. Oh, I need to catch up. Has anybody here ever run a carburetor in front of an M90 supercharger, feeding the M90 supercharger? Twin or single? How much does having a full-length exhaust affect performance? You can size the full-length exhaust after the turbo to not have any effect on it if it's big enough. Which is better, T4 flange or V-band? I don't think that makes any difference. What I have on mine is my Y pipe has a V-band. It ends in a V-band. And the reason I did that is not so I could put V-band turbos on it, although I could. I never have because I've never had a V-band turbo. But I do have V-band to T3, T4, and T6 adapters that I've made. So then I can put on any turbo that I want on that same Y pipe for the LS. I don't have another one of those for the other applications for like a small block Ford or big block Chevy, only for the LS. But that's what I do most of the turbo testing on anyway. So I can run a T3. I never have obviously on an LS, even a 4.8. I've never run a T3 on it, but I could. We run T4 and T6 stuff because that S475 Summit Racing, that's fairly common. So we can run both of those, and it's just a simple adapter. But now that I think about it, I could run V-band turbos as well. When is the Turbo 292 going to happen? Well, I already ran it once. Can you run a carburetor on a modern LT engine? Yes, you can. What combos do you run 1500cc injectors on? I've run it on 4.8s. I run on 5.3s. I run on 6.0s. We ran it on the big block. I think I ran the 1500s on the. We might have run those in the V6 also, but I'm not driving them around though. How much compression you pick up between a 317 and 862 head? I think it's more than one full point. Ball bearing versus journal bearing, which spools faster? I've never seen a true test of that. Would like to know a 351 Cleveland turbo cam to use. Frank, just pick out the cam that you want that does what you want in your NA 351 Cleveland, and then that's a really good turbo cam. Pablo, I ran if you're talking about the Gen 2 LT1, like in 96 or so, I cut a hole in the LT1 intake manifold and stuck a distributor in it. And I ran mine on the engine dyno like that because I didn't want to deal with the OptiSpark. And it worked. It's not what I would recommend, but they have carbureted intake manifolds for the LT1 that have a hole for the distributor. All you have to do is take out they have a little plug that they put in there. You just take it out and put a conventional distributor that works fine. Admiral, there's not a better between the V-band and the T4. That doesn't make any difference. That's not going to determine anything that happens with the turbo. David, I don't think most people use a vacuum secondary carburetor on those applications. People still have quick spool valves. I don't know if there's a company that makes them, though. Admiral, I would imagine ball bearing stuff is better for longevity, but I've never done a longevity test. Turboman 351, AFR 205, 351 Ford with F-cam. What turbo will make the most power to 900 horsepower? Well, I don't know what you mean by the most. If you pick a 900 horsepower turbo, which on that is going to be an S475 or an S480 for a 351, the amount of power that you make with the turbo is going to be a function of how much boost you run. So the best way to do that, if 900 horsepower was your clipped limit for some reason, I don't know why it would be, but your best option would then be to make the most power that you can below that 900 mark, which would mean you'd have to make a lot of torque. You'd be making way more torque than that motor would probably withstand. So don't worry about which one makes the most. get an S475 and put it on your motor, and it will all work out just fine. Admiral, the thing that people like about V-band clamps, and one of the reasons that I have one on mine, is so that we can orient the turbo. We can adjust it to make it fit. You know, if I have to angle the exhaust a certain way, or I have to turn it, mostly for me, it's for the configuring the discharge side of it going into the intercooler and stuff. Because sometimes we have to, it's a balance between, okay, will the exhaust hit the valve cover, or will the, can I orient this thing so that I can aim it, so I can use the bends that I have available to me without cutting and welding things, so I can make the discharge go into the intercooler and then the intercooler into the throttle body, wherever that is. That's one nice thing about being able to orient it with a V-band clamp. Ford 255 high output. Will a non-ported perform RPM for a small block Chevy cause some weird stuff going to a head that's a 1206 gas? No, it will be fine. As long as it seals, you'll be fine. How do you feel about compression with turbos? Would you rather stay below 10-1? We've run it on, I think an LS3 is up near 11-1. We've run it on factory stuff in Coyotes where it's that high. I think it's smarter to stay less than that. Richard, have you ever run a 1206 matched intake to a 1205 matched intake to a? Yeah, it's not going to make any difference at all. Port matching's a myth. Would you ever do a test with clip turbines and such to show what it actually does for power? I have done that, not on purpose. I had part of the exhaust go through the part of the gasket go through the turbine wheel and clip the wheel for me. I don't recommend it. Best turbo for a 5-liter, looking to make 700 to 800 ish. A GT45 is not going to do 800 on a small block Ford. The motor's too big for that, and you're gonna have to run a lot of boost unless you have a really good small block Ford going in. A 78, 75 or 76, 75 will both do that. And S475 is that's kind of right in the wheelhouse for that thing, or a 78, 75 Gen 2 like I have. Best turbo for a 4.6 GT45. You did not complete your 292 turbo engine runs with all the different intake manifolds. Is that a question or is that a statement? I'm not running the turbo with all the intake manifolds. As a matter of fact, I've already sent all those intake manifolds back to Tom. We'll do some more testing later on, but I'm not going to test all those under boost because all we have to do is test them NA, and then we know what they do under boost. I thought you're rebuilding. I am rebuilding the 292. It's actually, I think it's already done. It really wasn't needing to have the cylinder head done. Best turbo for a Predator carburetor? I don't know. Why don't people do high compression turbos? Because as you go up in boost and you go up in static compression, you have to go way up in octane, and most people don't want to do that. Roundy Rounder will Ford 390. I'm sure that's an FE at 9-1. Be a good candidate. Yes. What manifolds, headers, iron, 230 intake flow, 230. You can use the stock exhaust manifolds, or if somebody makes shorty headers for that, that would be good. A dual plane intake manifold is fine. A blow through carburetor. Hoon Squad. So a T76. The T76s from CX Racing are not going to do over 700 on a 5.3, or not much over that. But a 78, 75, or a real 76 millimeter, like the one that I ran from Precision, will definitely do over 700. It'll do over 1200. I don't quite get why turbine clipping is shunned. I don't know why you would want to clip the turbine. Why do you want to do that? Why wouldn't you just get a different turbo? Admiral, I wouldn't get well, VS is going to have stuff. Does Summit sell small turbos? The little 3076s would be good, or 3582s, or even like those 57 millimeters that I have, which I think were Borg Warners. Or you're trying to do 2000 plus? Oh, so you're going to need S475s for something like that. On 92 octane, what's a safe upper limit for boost? 9.8 to 1. It's not that simple. How detonation sensitive is your combination? An awful lot goes into that. So it's not just octane and boost, whatever the amount is. Okay, one more minute. The the question isn't foolish. It's just that you can't it's like asking how much boost can I run with the stock ring gap. Well, there's too many unknowns there. You don't know what the ring gap is. So what is stock? Is it 18? Is it 13? Is it 24? You don't know because you didn't take the motor apart. And even if you assumed that it was stock, it's from a wrecking yard. You don't know that it's stock anymore. So you don't know what it is. So that's a difficult question to answer. You also can't, nobody can answer you how much boost you can run on 93 octane, because what is the air temperature? What is the coolant temperature? What is the material that you're using for the cylinder head? Is that particular head detonation sensitive? Do you have a big variation in the 92 or 93 octane fuel that you're using in actual octane? Does it vary a lot from season to season like we have in California? Does it vary a lot from one load to another? Does it have, there's a lot of things that are going on there. And then the only thing that's going to happen is you can run as much timing as you want, or as much octane as or I'll get it right here one of these times, as much compression as you want. The only thing that's going to happen is you're just going to have to take all the timing out of it so that it doesn't detonate. But then that's no fun. Then you have other problems. Then you have high EGTs and all kinds of stuff. I don't know why you want to try to make as much compression as you want, as you can, and have the boost. Why don't you just put a turbo motor together that's 10 to 1 or less, and it's a turbo and it works and it always works and it works good, and just drive around and have fun with it? No, I got to have 10.2 to 1, or can I have 10.3 to 1? Can I have 10.4? None of that is, all of that's just argument stuff. So, Punk, you're going to send me an email on the bike? Cool. David, your Chevy 350 combo, 9 to 1, 215 heads, all of that sounds good. That's a 205/16 head is pretty big valves for a 212 camshaft, but it'll all work. I would always try to run E85 for a boosted application. There are guys that run it on pump gas. Again, you just have to take all the timing out of it. And when you do that, you lose a lot of power. Time for a ring gap episode. We've talked about that. Whenever I talked to Brule and when I was talking to Dulcich and Freiberger when they were out there, and this will be the last question for tonight, or it's actually more of a statement. We were talking about doing a test on, or I was telling them that I wanted to do a test on ring gap to find out how much would it take to actually lose power. Because I put stuff in there that was 30 or 35. I mean, at that point, I didn't even really care. We were trying to break the motor anyway. So if it was 31 or 32 or 35, it was enough. It was more than we needed. So we ran it and I didn't really see any change in power. So I would like to see at what point we start losing power. Like if I put 100 gap in it, would we lose power there? And obviously everyone's going to want, well, what if you did 100 on the top and 50 on the bottom, or 20 and 30 and, all these different combinations? That's not going to happen. We're not going to keep taking the motor apart and taking the pistons out of it and keep doing that test. We need to do once or twice where we can take it apart and do, an intermediate gap and then a big gap and go, okay, yes, somewhere we lose 4 here and then 20 here. So keep it in that range. It would kind of be what would happen, I'm sure. I was Jordan was mentioning leave the top ring out. I was wondering if we could get the motor to run with no rings in it. But I don't think it would start is the problem. Okay, guys, it is Saturday night. It's time to get going. I got to get out of here. Thank you guys all for showing up. Hopefully you've all taken a look at the turbo video because it's, chock full of turbo-y goodness. I'm working on some more stuff and I will get that up. Hopefully I'll have hopefully the 3800 heads are ported and done, and then I can airflow test those and we can run some tests on them. I'm just trying to figure out now what is the sequence of tests that I want to run, because right now we have on the motor on the 3800, I have the comp cam is in there. We have the L32 heads with the LS6 springs on it. I have the L32 blower on there with a 3-inch pulley and the stock throttle body. And I have a lot of stuff that I want to test. I got a bigger camshaft. I got ported heads. I want to chop the throttle body off of the back of the blower and put a big 3.5-inch tube so I can run a 90 or 92 millimeter throttle body or something on there. I bought a 2.5 or 2.6 inch pulley. I have an intercooler coming. Thank you, JPL. So we got a lot of stuff. And then also I have a bazillion things that I want to do with the turbo also. And so it'll be an interesting comparison. And I want to make sure that I do this with the same camshaft. I want to run turbo only at some boost, and then the blower only at some boost. And then show obviously what the difference in the boost curve is, because it's going to be, pronounced. And also what the difference in power is. So how much does a turbo 3.8 modified one make at 15 pounds of boost compared to the supercharger at 15 pounds of boost? And that will be a really interesting comparison, because that will get all the turbo blower guys all hopped up, and they'll get to see, as anybody would see if they've already taken a look at the videos that I posted, between a roots blower and a turbo, that the roots blower makes immediate boost and then falls off a lot in terms of efficiency and power compared to the turbo at any given boost level. So all of that will be very good stuff. Thank you guys all for showing up. I will see you guys all tomorrow.